Good morning students, I am Benil, Assistant Professor, Department of Computer Science and Engineering, Pondicherry College of Engineering. So in this video class, I am going to teach you about regular expression. So what is meant by regular expression? The regular expression is represented by RE. So if some terms you can see RE, that is called as regular expression. Okay, right. And the definition of regular expression is we can easily describe the finite automata in this regular expression. Okay, so you know what is meant by finite automata, and the relationship between regular expression is finite automata. It is like states and represent like states, starting state, for example Q0 and Q1, A, B, A comma B. So this is called as finite automata. The same thing we can represent in regular expression in easiest way. Okay, no need to draw this diagram and no need to represent like this. So we can easily represent the finite automata in this regular expression. Okay, so I will tell you how we will represent regular expression. The general form of regular expression is Rij power k. This is very important. Rij power k. So here I represent starting state. I represent starting state, okay, and J represent accepting state, okay, and K represent number of states, and R is a regular expression. Okay, so I will tell you how we will represent. See, R is a regular expression, and I represent starting state, and J represent accepting state, K represent number of state. For example, in a regular expression, if you have the state mentioned as 1 and 2, if you have the finite automata like this, I can easily represent regular expression like R is a regular expression. What is I? It is a starting state. Here, which one in this finite automata, which state is a starting state? This 1 is a starting state. How? The state which contains this small arrow, that is called the starting state. So 1 is the starting state. So R1, and which one is accepting state? This state is an accepting state. Why? It is marked as double circle. So this is an accepting state. So accepting state is 2. So R12 power K is a number of states. How many states are here in this finite automata? 2 states. That is 1 and 2. So R12 power 2. This is the regular expression for this finite automata. Can you understand? So the thing is, we can represent the finite automata in the easiest way. Okay, no need to draw like this, and no need to represent that transition table, etc. No need. So we can represent the finite automata in the easiest way. That is called as regular expression. So this is the second unit. We are going to study about regular expression, and you should know about this concept very clearly. Rij power k. This is a regular expression, right? So how we will represent and how we will do regular expressions, and you should remember what are the things we can do in finite automata, like NFA to DFA conversion and epsilon NFA. Everything we can do in a regular expressions manner also. Okay, because both are same, but in regular expression we are easily describing, right? So another definition of regular expression is, see, let sigma, you know what is sigma? What is sigma? Sigma is an first unit we studied. What is sigma? Is an alphabet. Okay, alphabet. For example, 0, 1. 2 input symbol, that is sigma. Okay. And what is capital Q? Number of state. Just remember. Let sigma be an alphabet. For example, like this. Sigma be an alphabet. The regular expression over sigma and the regular sets are defined as, how we will define the regular set is, if the alphabet is empty, okay, pi empty. If the alphabet is empty, then the regular set is defined as empty set. Okay, if the alphabet is empty in the set, it is empty, then in regular expression we can define the regular set as empty set. Okay, and second one, if epsilon is a regular expression, then we will mark it as a regular set as epsilon. So if it is epsilon also empty. If it is epsilon, then we will mark it as epsilon. This is regular set. Okay, and for each A, if A is a regular expression, that means if sigma have A, that means if sigma have A, alphabet have A, we will represent the regular set as A. So if you have A as an alphabet, we will represent as A. Okay. If R and S are regular expression, that is if R and S, there is a two sets of regular expression, then we can represent the regular set as R, then where it is S, R plus S, R into S and R star. Very important. If you have two sets, okay, I can represent R plus S and R into S and R star, right? Okay, so the language associated with the expression R and L of R. So there is an example. See, if we can write L of R1 plus R2, we can write L of R1 plus L of R2. L into R1, R2, we can write one language and another one language. L star, we can write L of R1 the whole star. Okay, so very important. This point is very important because we are going to use this point is often. Right, so this is the definition of regular expression. Once again, if that is pi, that is empty set. Epsilon, we will set inside, we will mark it as epsilon. A, that means one alphabet is there, we can mark it as denoted regular set as set of A. If there is a two sets, R and S, there is the R plus S, R into S and R star S. That's what's mentioning here, okay. So this is the definition of regular expression. And very important thing, precedence of regular expression. Right, clear? Precedence means, I told you, before that we will study precedence, we will see later that we will study the operators of regular expression. Operators of regular expression. I told you there is a two operator. One is union, and another one is concatenation, and third one is closure. Right? Union, concatenation, closure. That's what I mentioned. Union, I will represent it as R plus S, and concatenation R dot S, and closure R star. Okay, union R plus S and dot and star. Okay, this is the operators of regular expression. Union, concatenation and closure. Okay, then we will study the precedence of regular expressions. Precedence, we have three operators. Which one we are going to give highest precedence? First we will give the precedence as dot. Okay, concatenation operator. Dot will give a first precedence. Second we will give a precedence star. Okay, and third we will give a precedence plus. It means concatenation, closure and union. Okay, so this is the precedence of operator. While doing a problem, it may use. I will ask you what is the precedence of regular expression. You want to tell first one is dot, that means concatenation, and this is closure, and this is plus, that means union. Okay, and what is R star? What is R star? I will explain you what is R star. So in finite automata, we will study Q1 0, 0. Okay, if you have a finite automata like this, what is Q1 delta function? Delta of what is Q1 is Q1, right? Q1. So I will mention, I can write Q1 0, 1 times 0, 2 times 0, or etc. Number of times 0, it looping here, right? See, looping structure is here. That is, I can say 0 or 0, 0 or 0, 0, 0, 3 times, 4 times, 5 times. Inside the set, it is infinite, it is going infinite. If it is like this, Q2, if it is like this, 0, that is only one transition. That means Q1 it reads 0, goes to Q2. There is no loop, right? So if it is like 1, so 1 is infinite. This is called a closure. That means Q2 star. That means 1 is infinite. Okay, ready? So Q2 star, that is infinite. Okay, so this is the closure operation. That is star, right? Okay, so this is the regular expressions basic concept. So I told you regular expression denoted by Rij power k, Rij power k. What is I? Starting state. J is an accepting state. K is a number of state. And this is a definition. And then we studied precedence function. So we will give first precedence dot. That means concatenation. Second is closure. Third one is union. Okay. And then I told you what is star operation. Okay, so remaining the problem we'll see in the next class. Thank you.